skating. I also swim. I come from the coast region of Kenya, so of course I have to swim. And I also do drumming when I'm free. But I've not done it in a minute, so I should probably do some catch-up lessons. So that's me. So during the call, feel free to ask me anything around what I've introduced. That's why I've tried to introduce myself in all those perspectives. This is a small call where we're just chatting and getting to know more about each other. So feel free to drop any question on the same. I hope you can see my screen.
Yeah, we can see it, but it would be good if it was just a little bit bigger. Right, everybody?
Okay, so
Oh, cool.
let me let me do this then. Let me just stop it, then start again. Just a minute. Let me just do that and then come here, and then do it again. So let me just escape. So just a moment. 1, 2. Okay. So, but as I try and share my screen again, maybe you can share with me how many of you have done machine learning before? Like you've done machine learning and you've even built a machine learning model before. You can just unmute or drop a one in the chat section. We're not many of us. So if you've ever built a machine learning model before, you can just drop one in the chat section. If you've ever built a machine learning. Okay, if you've heard of machine learning, you know what it is, but you've never ventured into it. You're like, I'm a web person, I built the web, I do JavaScript and all that stuff. You can drop two in the chat section. You know what machine learning is, but you've never taken time to oh, let me try out this thing and see maybe what it is. But if someone asks you, you can clearly define what you understand by machine learning. Okay, Precious is a Web3 person, you know. So if you've done it before, you've not done it before, but you've just heard about it and you're like, oh, this is an interesting thing, but nah, I do crowdsource. I know Divine is here. Divine is a crowdsource person. So nah, just do my crowdsource thing. That's enough. And if you've okay, I can, maybe this thing is more maths into it, so I'll not just do it. Only Precious
Okay.
has.
This is an interactive session, so please, get into the discussion, drop comments, and be interactive. We're just 11 people here, so I expect everyone to contribute. That's why it's a smaller group, right? Yeah. So try to answer questions. Now we're seeing more information flying. So Ido says he has built machine learning model before. Bryan,
Okay.
take a continue. Yeah.
Yeah, nice. So great to hear that. So today now we'll be looking at how you can integrate machine learning into your web apps or into your web apps and into your Android apps. But I had planned this session for to be specifically for Android apps. But of course, we can always see and learn together. So I said I might change the code since I've noticed most of you do not probably do Android, but I'll try and explain because the implementation is still the same even when you're using MediaPipe on the web. So let me just share my screen again. So here we go. Thing. So I'll be presenting this. Slide. Yeah, just okay. There. Share screen. Present this one. Okay. Share. And then I should enter presenter. I should slideshow. Yep. Now you should be able to see my screen like full screen. Should be better compared to the other time. Okay, so just before we go into MediaPipe, I want to share a little story that will make us understand what exactly MediaPipe is. So Paukwa Pakawa is a statement in Swahili, which we use when we want to start making stories to someone. So I say Paukwa Pakawa. When you come to Kenya next time, I'll probably teach you more Swahili. But today, Paukwa Pakawa is a statement we say when you want to share a story. So I want to share a story with you that from there now we will be able to build on it and understand exactly what media pipe from a non-technical perspective. So I want to give you an explanation from a non-technical perspective. So when I was young, I studied at a primary school. In Kenya, you have like primary school, then you go to high school. I studied at a primary school which was in the semi-arid and arid areas of the coastal region of Kenya, that is in Ganze sub-county. So it was called Ganze Primary School. So in our primary school, in primary schools around the arid and semi-arid areas, the government noticed that many kids were dropping out of school and were not going to school. So they like tried to, hey, what's happening in these areas? So they formed a cohort. They formed an ad hoc committee, and this ad hoc committee was like trying to see why are kids not going to school, why are kids dropping out of school. So when doing that, the government found that kids who are not going to school because the kids don't even have food at their homes, so they feel like they should just engage in other activities to even put food on the table. So with this, they launched a feeding program in our schools. So we went to school. We had even plates there. Everything is in school. You just go. You'll get lunch. You'll get first of all you have to get 10 o'clock tea, and then you also get lunch. So like it was just to bring more students to come to school. But after doing that, the government still found that we still have not many people coming to school. So what's happening? So when they invested more into that effort, they also find out that many students in the region are suffering from giga infestation because of lack of proper shoes and uniform to go to school. So they again came up with a program where they are giving shoes to kids in my primary school. So the shoes were called Toms. They were rubber shoes. So we were given shoes. And they also had other programs, of course, that they were also giving us books in school. So our parents didn't have to buy books. We had books in school. We had school shoes to go to school, and we had meals in school. So you see, like this made more kids come to school compared to before. So how is MediaPipe? So MediaPipe is a tool that we can use and anyone can use. But machine learning has a lot of concepts. You have cosine similarity. We have all those big mathematics that many people feel like this is too much for me. So Google saw that that is limiting other practitioners to do this. So how can they help us? How can they help the other practitioners who are not machine learning engineers to also integrate machine learning into their apps, or also bring these smart features into their web apps or their Android apps? So they came up with a tool called MediaPipe. So MediaPipe is a tool that has different tasks that can help you to integrate machine learning into your web app. So we have what we call MediaPipe tasks. So MediaPipe task is like one of the things, like the government giving us food. So a MediaPipe task is where you can do different tasks like natural language processing, computer vision, and audio in your app. So you can bring these different tasks into your app. But also, let's say you want to customize the experience. So the government was giving us books, but they will not come to class and teach us what to do. So we have to take the books and write the notes and learn from our teachers. So that is MediaPipe Model Maker. So with MediaPipe Model Maker, you are a web person, but let's say you want to solve the problem of female genital mutilation in West Africa, and you want to collect data specifically from Western Africa. So you take this data from West Africa, you take a model that already exists, you perform what we call transfer learning, which I will explain, where you use your data and use this model that's already built, only using the top layers and the bottom layers of the machine learning model, and not necessarily building the whole model, and then have a personalized result. So you see, like that is something personalized. That is what we call MediaPipe Model Maker. So the government giving us books when we in primary school, it was just like trying to help us. Hey, we are giving you books, but you're the ones who are going to actually do the stuff here. And then you have what we call MediaPipe Studio. So MediaPipe Studio is on the cloud. So let's say you want to test something out. You want to test this model before you actually bring it to your app. You want to test this feature before you actually bring it out in your app. We have what we call MediaPipe Studio for you. So MediaPipe Studio is running on the web. You can just go upload this model or try out these different features that I'm talking about, and we'll be able to see what exactly is MediaPipe Studio and what exactly is MediaPipe Model Maker and MediaPipe Tasks before I proceed. So before I continue, Do you now understand what media pipe model maker is? You can unmute or you can drop a one in the chat section if you now understand. And you can even explain to someone what media pipe is. But if you have a question you want me to explain further, also feel free to share. This is an interactive session and we are talking to each other. I'm not the only one speaking. So we are interacting with each other and learning from each other. So if I at least explained media pipe in a way that you at least now understand, you can drop a one in the chat section. Yeah. Okay.
We could type, we could chat. Please, it's supposed to be a very interactive session.
Yeah, it will be a very, very interactive session.
So let's have contributors. Should we call names?
Yeah, because I can't proceed if you. Oh, okay. Oh, okay. Nice, nice. Thank you. Thank you so much. So now people, I get now, at least now people have understood the concept of, oh, I didn't follow everything. Hello, Sieg. Maybe you can share exactly where I lost you, or you can share maybe where you didn't specifically understand. So let me just break it down before I proceed for you. So MediaPipe is a tool that can help you as a mobile developer or as a web developer or as someone who is not necessarily a machine learning engineer, bring the machine learning features into your either your web app or your Android app. So that's just a basic explanation. It's a tool to help you do that. And to help you do that, it has three different features. Yep. So MediaPipe is used to deploy machine learning models. But it's more than that, and we'll see how exactly it is more than that, because it's also giving you more power as a developer. So yeah, thank you very much for also dropping that. So I feel like now I get
Sorry,
you.
excuse me.
Hmm.
Okay, so it's used for deploying without writing codes, right? It's a ready-made tool, a no-code tool.
No, it's not necessarily a ready-made no-code tool, but you just have to integrate it into. You have to write a little code, which I will show you here live. I will try and explain it to you live here so that you see the little code that you have to write to bring it into your application. So for example, I explained about media pipe tasks. So for media pipe tasks, everything is just made for you. So like have these models that already exist. So we have in the TensorFlow hub. So they have those models bundled up. And what to use, you just have to specify which model you're using and which task. Is it a natural language processing task? Is it a computer vision task and all those? But I will explain all these tasks in a step-by-step way so that we all understand and are all in the same page. So yeah, but it's close to what you shared. It's just a deployment tool that you can use. So now let's go and see what exactly is under the hood, and I explain it to you better so that you get the concept. So in traditional programming, this is when you're writing code in JavaScript or in Python. We take a known input and a known function. So we just take this known input and a known function, and then we take a known input and a known output or a set of rules to produce an output. Oh, this should be here. Yeah. We take a known input and a set of rules. Let's say I want to find the addition of 1 plus 1. So I'll say 1 plus 1. What do I need to get 1 plus 1? I need three variables with two integers and one to store what I'm calculating. Then I'll take the one, I'll plus with the two to give me an answer. So that is traditional programming. We just take a known input and unknown rules to give us the output. This is in traditional programming. But now in machine learning, it takes a set of known inputs and output. So in the traditional programming, we only know the input, but we don't know the output, and we use the rules to give us the output. But in machine learning, we take a set of known inputs and outputs and try to figure out what the function between the two, so that the outputs can be generated based on the new inputs. So you see, we take this known input and a known output, and then we perform machine learning here, and then we find out the set of rules. And then now we'll take these rules, give them an input that it doesn't know, and it will be able to predict to us the output. So this is mostly out of the scope of this presentation, but I just want to give you like an overview of exactly what machine learning is and what we'll be tackling. So, mhm, yeah. So we have, okay, we have, I think it went, yeah, here. So machine learning necessarily gives you predictions. It does not provide exact answers, nor do they provide correct answers. Even when you use ChatGPT, use BART, use Bing, it doesn't provide you exact answers. It just gives you predictions from what you provided as an input. And what I really love to say is that it is a language model and it is not a knowledge model. So when you're using ChatGPT and using BART and you're using Bing and it lies to you and tells you, oh, when you search who is Precious Nzema, and it tells you Precious Nzema is, let's say, a machine learning engineer. Precious Nzema has done this and this for the community, and it's all lies. So it's because it's not a knowledge model. It actually doesn't know who Precious is and all that, but it's just a language model. So it just gives you predictions and doesn't provide you with exact answers. So as we move on, models, what they can do is they can make predictions and they should be used as a tool to guide our decision making. So they should just guide us in decision making and not necessarily be used as tools for giving us correct answers. So ML is to assist you to do things that are difficult to do with with a more traditional programming technique. So functionality that is difficult to replicate without ML. So it's not the solution to everything as we proceed necessarily, but it's just to help you to do things that are difficult to do in your model. So let's say you want to integrate in your app. Let's say you're building an app. I'll just use the same example that is used to help mitigate female genital mutilation in Western Africa. So, and in this app, you want to have a part where it will automatically suggest, it will like give you predictions of the hotspot areas in a specific state. So, like from previous data. Can you do this with traditional programming techniques? No, it will be hard, but you can easily do it with machine learning. So, yeah, before you proceed, I hope we are all together in the concept of machine learning now. I hope we now get what ML is and what we are supposed to do. Okay. Thank you very much, Sheikh. Yeah, thank you. Yeah, thank you so much. So now let's understand what on-device machine learning is. That is machine learning in general, but this session was for on-device machine learning. So machine learning is on-device machine learning is machine learning that happens on your device. So it's not something that happens on, let's say, you're doing it somewhere else. So with this machine learning, it is taking place. Let's say you're having an Android app. So the model will run on the app, not on anywhere but anything. It will just run on your own app. So with this, that means that you can run inference more directly without cutting out transit time. So it means you have low latency and close-knit interaction. With this, I mean when I'm sending things to the cloud and then expecting feedback to come from the cloud, it will have some latency. It will not like be as fast as it's supposed to be, but it will have some latency. But when I'm doing everything on my device, like everything is done and computed on my own device, it will be more, the latency will be low and the interactions will be close knit. And then another thing is offline availability. So when I'm running on-device machine learning on my device, even if the internet connectivity is not there, so just to share, internet connectivity probably is something that is affecting most of the African countries. And when you're building a product for Africa, it should be something that you should have in mind. It's not like something you're proud of and you're actually working to mitigate it, but it's something that is existing. So if you're building a product or an app that people should use, it should be offline. It should be an offline fast app where you should be able to use it even if the internet is not available. And with on-device machine learning, it allows you to run machine learning models on a device even when you don't have internet connectivity. So this is another advantage of having machine learning. And then another thing, it is privacy preserving. The data doesn't leave the user's device. Everything happens on the device. The data is collected on that device. What I just pushed to the device is the model, but the data comes from the device and everything is run from the device. So the privacy is being preserved and nothing leaves your device. So you see, like, you can also ensure that your users have enough privacy for when using your app. So now that was like the intro part. Now was just me giving you an overview of everything and on device and ML. I hope no one is lost and we are moving on together, understanding this. So now let me share with you everything media pipe. So from here onwards, we'll be discussing media pipe and how you can deploy machine learning models on your Android devices easily with media pipe. So, yep. The first thing we need to understand when we want to bring machine learning models to our device is that the model is the heart of on-device ML. So the machine learning model you're putting there is the heart of everything. You will take a single model, bundle it into your program, and have it run on the program. As you can see, I have an ML app. We have input, and the model is the central part, and the output is what this is what the user will input, and this is what the output the user will get. But also, we usually have like some when you computational power can be optimized. So you see, like sometimes it depends on the devices that you're using. You can't compare if you're running machine learning models on, let's say, a Techno device and you're running machine learning models on a Pixel 7 Pro device. So the computational power will be different. The needs for those two devices are different, and the way you'll be running them is also different. So the good thing is you can customize it to ad hoc use cases. When you're using ML on device machine learning, the power is on you. You can customize it to different ad hoc cases you want. It is lightweight and efficient. This is something that you don't have to like build a model that is so big. You just have something light and efficient, and that is what MediaPipe is providing us. And it also targets to hardware. So you have different hardwares that exist. So different, we have CPUs and all those. So this is for, let's say you're running this on an Intel device, and you're running this on another, let's say, iOS device. So the type of hardware are different, and you can specify this for best performance for your device. As I said, the power is on you, the developer now, since you're doing on-device machine learning, and you can have this customized to your needs. So machine learning pipeline, they streamline the process from raw inputs to outputs. So when I'm doing machine learning, we streamline the process. So whether you're using just a model or an ML pipeline, you just have to build a machine learning model. And that is what by makes web developers and all that feel like, do I really have to add this? And I need to look for data scientists to help me bring this into this. But now you can actually do this on your own instead of requesting for someone else. Because now the ML pipeline is being streamlined, the processes from raw inputs to output results. All this is what you'll be able to see. Like we have the live camera. Let's say I'm building an app that can help me, let's say, get, for example, I shared earlier about Giga infestation. So I'm building an app to help me, let's say, have different advocates share their experiences when they're doing Giga Nani, the advocacy in the villages. So I have this live camera app. So you see, like all this is what you will be able to see. But now I want to show you what happens behind the scenes. So what has been abstracted from you is this. So this involves much complexity that hinders fast development. So you see, we have buffer management, data sampling, image filtering. All of these are things that you would have to worry as a mobile developer if you wanted to do all this stuff. And that is what you want to make it easy for you and make sure that you can now bring these features into your apps in an easy manner. So now MediaPipe abstracts all that complexity into what we call MediaPipe tasks. So you see from this part, so all this is abstracted. You will just have to input the value. Let's say I'm doing a video, and you just get the display on outside. So you see, this is what MediaPipe Task offered, which I shared there. We have three services: MediaPipe Tasks, MediaPipe Model Maker, and MediaPipe Studio. So this is what MediaPipe Task does. It abstracts this and allows you to bring machine learning models in your app just in an easy way, while meeting your needs for custom modeling. So I've shared that sometimes you want something that is custom made. For the example I shared about mitigating premarital mutilation in the West Africa, so you have to get data from West Africa. You cannot use data, let's say, from East Africa or from South Africa or from the Northern Africa countries. You have to get data from those West African countries. So if you want to custom model something, this is what the tool that you'll use, what you call MediaPipe Model Maker. Then we have now also what I shared, what we call MediaPipe Studio, which is a no-code GUI with MediaPipe Studio, where you don't need to code anything. You can just go and try out all that. So I will just drop a link in the chat section so that we proceed. Yeah. Maybe the co-host, you can also let me know in case we have questions in the chat section while I'm sharing. So up to there, I hope now we understand all the three tasks that exist on MediaPipe, and we have the tasks, the model maker, and the no-code GUI, that is the MediaPipe Studio. Yeah, I hope we are all together and it's not too much to take in. You can just reply with one if you're still following along and all is well. Okay, thank you. Thank you. Thank you, Kanu. Okay, nice, nice. So now we have different platforms that are supported by tasks. So we have Android, we have web, we have Python, we have C++, and if you're an iOS developer in the house, it is coming soon for you. So all these are platforms that you can perform MediaPipe tasks on. So you can get customizable high performance on device ML solutions through a low code API. So here you just be using APIs to perform all these things in very little code. So if you are trying to build something with text, you can do all these are the products that you have. You have natural language classification, you have text embedding, text search, question and answer, dialogue understanding. Of course, all these are not things that you should worry about as an Android developer. Or let's say if you're working on a team with other developers, you can just reach out to the data science team, or if you have a friend and they can explain to you what all this is. We have also have products on vision, which is image classification, object detection, image selfie segmentation, all these post detection that you can use. And then we have audio. We have audio classification and audio embedding. And I will be sharing with you today all this. And we have many more, but many that you can use. So now let's get to the real deal of the talk today. Image classification. So let's say I have built an app. Okay, I also want someone to share like their use case. What have you always wanted to add? Okay, maybe you've never wanted to add, but if you had a chance to add a feature about on image classification in your app, so what would you want to add, or what problem would you want to solve with image classification? I want to be the one giving out the some example features. So anyone who is up for this, what is you feel like this is a problem that I can solve with machine learning and specifically image classification in this app? So image classification is just you're using images. Your product should be containing images. Even if it's identifying cats and dogs, even if it's identifying different wildlife in Nigeria that probably are not available in the different parts of Africa. I'm sure you have wildlife that is specifically for Nigeria. Like example, you have white rhinos in Kenya and they're endangered species. So if you want to see white rhinos, you have to come to Kenya to see white rhinos in Africa. So maybe something fun about Nigeria that you'll want to share with others through image classification. Anyone who's up for that? Okay, so I'll just share mine as we proceed. I'm sure as we proceed, you'll get a more clearer view of image classification and all that. So image classification is like the hello world of computer vision, and we're saying computer vision. So let's see. In the slide that you're seeing right now, you have, when I ask you what can you see, you'll probably say One will say I'm seeing a cat. One will say I'm seeing probably that is a wardrobe or a cabinet. Another one will say I'm seeing a rug. Another one will say I'm seeing a toy. So you see, we have a cat, but here we also have a rug and a toy here that are also in this picture. So now I would want to automatically identify what is in this picture. It's because I have seen it. But let's say someone doesn't have the ability to see. In one of my, let's say, one of my family members doesn't have the ability to see, and I want to give them a chance to also experience the surroundings around our house. So I want to give them a chance to also experience the surroundings around our. Okay, sorry about that. I hope I'm back, and I want them to. I want them to feel. Hope you can still hear me. Someone was just calling me, so probably might have. Oh, okay, sure. So let's say one of us in our family is not able to see. So I want to give them a feel of what is in our surrounding. So there's this cat in our house. So I want to identify this cat and be able to share with them that this is actually a cat that is standing in front of you right now. So what I will do, I will start by identifying the different. Let's look at how. Let's now see how classification happens. So the underlying model uses something that we call convolutional neural networks. So these tools are the main way, are the main approach to image classification. So it is just to look at the different patterns in the image during training. So let's now see what can make me say this is a cat. The characteristics. So the first thing is we have the ears. So the ears look like that. This is a typical ears of a cat. And then we have the eyes. These are typical eyes of a cat. So yeah, these are typical eyes of a cat. So if I have a picture and the eyes are closer to this, it will be nearly a cat. And then we have this nose is typically for a cat. So you see, I have first selected the features in this image. I've selected the feature that we have these ears, these eyes, and this nose. So this is what will be telling our model that this is a cat. Our model doesn't know that this is a cat. But if it sees a picture with these features, we say, oh, I think we have these ears, they're similar to the other image, the eyes are similar, and the nose is similar. So you say that, oh, this image is of a cat. So as I told you, when I give it a new picture, it will take those patterns and look at a brand new picture, and it will be able to identify it and say with a certain percentage of confidence that this is an image of a cat compared to the other image I saw earlier. So now we've seen what we call feature selection. So we've selected different features. So let's say I was coming. I'm in Lagos. So I'm also coming with my relative who is not able to see. So I also want to give them a feel of Lagos. So what are some of the key things about Lagos? What are some of the key features about Lagos? Either in the streets or something that I will see around the city that will make them know that I'm in Lagos, Nigeria, and I'm not in Nairobi, Kenya. So if you come to Nairobi, Kenya, the key things that you'll probably see, you'll see the KCC, which is a building that is just around town, around the center of the city. You'll also see what we call the archives, the National Archives. This is just around saying. So those are buildings. And if you want to see, let's say, statues, you'll see statues of one of our freedom fighters that is, the different freedom fighters that we've had. If you want to see forests, you'll see one of the Karura forests that Wangari Maathai fought for and won a Nobel Prize for. So you see, these are typical things about Nairobi, features that people know and people know that exist. So the same way when you think of image classification is just selecting typical things that people know that, oh, this is a man, or this is a human being, this is a cat, this is a dog, and this is what. So what I'm trying to pass across is that the model doesn't know that that is a cat, but it tries to compare it with the features it saw earlier, the ears, how the eyes look, how the nose looks, and you're able to say like, hey, this is a cat. So now we've seen how we can select the features and patterns. So now let's proceed and see how when we take those patterns. So when I take those patterns and look at a brand new image, so now I'm looking at a brand new image, and they can say that this is a cat. So now this is like what happens. So the classification happens across multiple layers of an image. So I'm sure you've seen the RGB color code. So I'm uploading an image that is in RGB. So when it takes those colors in several layers and tries to perform classification from the various patterns that we have. So I take the red layer, the green layer, and the blue layer. So what I'll be able to gather from the red layer is not the same of what I'll see in the green layer and what I'll see in the blue layer. So, for example, when you look at the red layer, you may notice several features. We might not notice in the blue. The idea is just to combine them and have a more understanding of what is really happening in these images and how we are classifying them. So this is just a brief overview of what convolutional neural networks do behind the scenes. But that is not the scope of our talk today. So finally, okay, I wanted to go back. Okay, we're already here. So finally, the images will need to go through a few processing to scale. So this is like a demo that you can see here. This I'm selecting image. You can see this is me selecting an image from a phone, and you can see that image is being classified as something, as an animal. So this is what exactly you can do with MediaPipe, what you're seeing on your screen. If you're building, let's say, an Android app and what, this is what you can do on your device. But now let's see how we are going to implement this image classification for our Android app. So let's say I'm building an Android app and I want to implement this in my app. So this is the first thing. First things first. So when you're building anything, you have to import the specific libraries. So if you're building, let's say you're building an app, you have to do Node.js. Those are the normal things that you use. Node.js probably, or if I'm doing machine learning, I have to do pandas or all that. But for you, you're not a machine learning developer. So you're building on Android, so you just install this. You just have to call this dependency, and you call the task. It's called task vision. So here I'm doing image classification. So it is a vision task. So I do that task. Then after that, now I want to set up my image classifier. So this is a specific example for Android, but it's not different from what you'll be doing in your web app or in something. I just want to explain everything that you are seeing right now. So what you're doing basically in this code, hope for those that don't do that, have never done machine learning before or don't do Android, please don't feel scared. This is something so easy, and I want to explain it to you today in a very simple manner. Such that the next time you're going to, when you're building an Android, you'll be like, oh, okay, so this is what Bryan was saying during the meeting. This is so easy and so all that. So yeah, don't feel scared. Let's just go check this step by step, and at the end, we'll try to see like what exactly I was saying. So what you're doing here is you're creating the object that will do the classification. So we all understand object-oriented programming. So everything is an object. So here I'm creating an object that will do the classification for me. So the pattern is going to be standard across all the features. So if let's say I want a natural language processing feature, or I want a vision feature, or I want an audio feature, the pattern is going to be the same. But now I'm just creating an object. So let me now explain to you line by line what I'm actually doing with this. So there are two options. So here now I'm just specifying two options that will be combined to make the classifier. So the first one is the base option, which which one can create using a builder pattern. So if you are doing Android, you just create the two options using a builder pattern, and it will be easy for you. So and after that, after I've done that, the first property we are going to set will be the delegate will be the hardware part. So you're going to perform machine learning on which device. So this is what I'm doing here. So I want you to say that I've had a delegate CPU. So let's say I was doing this I was performing TinyML. So this is, let's say, on an Arduino Nano RP2040. I was doing this on an Arduino board, or I was doing this, let's say, on a different device. I also specify here, or edge TPU, or all that. So what basically I'm trying to do in this line is I'm just specifying the hardware. So I'm just specifying I'm going to be performing all this classification on a CPU. So that's it. That's what I'm just trying to share there. So let's see what these next two lines are doing. So in the next two lines is just me saying to my app. So hey, my Android app, I have this model that is called efficient light and is stored in a TensorFlow light file. So it's a .tf file. I'm just telling my app, hey, I have this model which I already made and it's included in my app. So when you are doing this, if you're an Android developer, what you do is you just download the model and then you add it to your Android assets folder. So when you're in the Android assets folder, you add the model and you will be calling that name of that model here. It has a TF Lite extension. So there are different types of models from the TensorFlow hub, of course. But as I said, I'm going to simplify things here. What I'm trying to do here is I'm just trying to tell my machine learning model, hey, I had this model that I created earlier. It is already made. It is included in my app. So let's go ahead and use this one by title and then create a base option. So let's go and use this one by this title and then create a base option. Also, if you just create your own machine learning model, you will just create it personally. If you're using Model Maker, create it, give it a name, then you come here, you specify that name. So you see, very simple. So let's continue, and as I share with you what this. So now let's look at this part. So in this next block is where we're going to create the image classifier. So here I was just setting up, the options, but now I want to create the image classifier option that are specific to the image classifier itself. So like these ones are specific to, hey, this is an image classifier and it's specific to what I imported here. So like my model, and I'm putting it there. So yep. And now let's see what this part is. So if you've heard of machine learning, you've probably heard of what they call accuracy. So we have machine learning. My model is 80% accurate. My what is this percent accurate? So this is what you'll be specifying here. So you have what you call the threshold. So when I set the score threshold, is just the minimum confidence that the model needs to have before it runs the result. So for example, I'm running this model, of course. I'm using the same example to mitigate female genital mutilation in the Western Africa. And I want to make sure that before the user gets results of this prediction, the model is 60% confident that that place indeed is Lagos State, or that place in it is Uyo State. So is in Uyo, sorry. So that state is Uyo. So I'll be saying that in the threshold part, instead of having this word threshold, I'll be saying 0.6. So that will be 60% confident of what the user will see. So the user will only see if it's 60%. If it's not 60%, the user is not going to see any result. Now I hope you get that part. And what you have next is max result. As I shared earlier, we are doing predictions in our model. Our model is giving us predictions, and sometimes it may give us more than one prediction. It may say like this one can be a cat, but for a cat I'm 70% sure, and it can be a dog which I'm 60% sure, and it can be this and I'm this percent sure. So you have like three results, three predictions. But now for us, the user wants to only see a specific number of predictions that you want your user to see. So what you'll be doing here, you'll be saying, if I specify this to be 5, the user will only be able to see the top 5 results that my model will provide. I hope now we are getting each other. It will only be the top 5 predictions. So the one with 70, the one with 60, and the one with 40 will be the one that is given an option, and the other ones will not be shown to the user. And then now we have running mode. So now let me explain what running mode is. So for running mode is I might decide to be using this using live stream. Let's say when someone goes live on their phone, when someone is, let's say, in Lagos and they are taking videos, the video is automatic is able to tell them that, hey, that is, I'm not sure of the features in Lagos, but it's able to tell them that this is a so and so bridge, or this is a statue for so and so. It's able to tell them that on live stream. But now we also want someone who just wants to upload a picture. So someone just clicks this thing, uploads a picture, and they're able to get results. So you see, one is live stream, another one is I'm just uploading a picture, it's the static, I'm just add photo and then I'm adding a photo. So here, that is what you specify here on running mode. Do you want live stream? Is this person going to be doing it as a video? And going forward, I'm going to share with you the live stream option so that you understand. If you understand the live stream option, the other options will be easy for you to understand. So that one is this one here. So yep. Now let's proceed And now we have the last part. So now in this last step, we are going to just pick the initial base options that we created, these ones here, and that are universal across all the APIs and associated with the image classifier. So what we are doing here is universal across everything. But what will happen here now is what exactly we are specifying for our users. So now we are taking all the two options and having them. We are just going to pick the initial base options and associate it with the image classifier options. So yeah, now I don't want to proceed here. I just want to make sure that we are all together. I know this is a lot. Wow. Just want to hear from you. Is it interesting? Someone hand is raised. Hi Daniel. Okay, sure, maybe you had clicked that by mistake. But also, if you have any questions, please drop it in the chat section so that. Oh, nice, Kanu. Yeah, 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 sure. Oh, nice, nice. I love it. I extremely love my audience. So I'm trying to break down this concept. So now let's see the next time. So I say that we're going to be using live stream running mode. So we have, of course, and we have images and video files. So now here, going forward in this task, we'll be using live streaming mode. So we are together today. We are going to be using live streaming mode. So since I'm working with live streaming mode option here, and live streaming performs all these operations asynchronously, you are required to associate the results, a result listener and an error listener. So now let me explain what I mean by everything is happening asynchronously. This is not different from what you've been learning before, but now when I'm doing live stream mode, things are coming in and are being, so if I'm doing a video, I'll be taking a specific part of that video, passing it to my classifier, getting the results from that, sharing them to the user, picking the next frame of the video as we continue. So I'll be accepting frames as we go of this video coming in. It's a live stream, so I'm getting video frames coming in for me to classify as we move on. So if the camera frames are coming in faster than the inference being performed, what will happen is that the pipeline itself is going to drop the older frames so that it is not continuously falling behind as that inference and frame rate times essentially diverge, so that it is continuously running fairly smoothly and just taking the newest frame and passing it across to our classifier. So let me now break it down. When I'm building this thing, my user is going to be streaming, is on Snapchat, or they are on, let's say, on Snapchat streaming live or Instagram. And this thing is coming in. So my app is taking in the video. When I'm taking in the video, the camera frames might be coming in faster than how my inferences perform, or than how my model can perform prediction on that frame. So when that is happening, the model is able to drop the old ones so that it can give the user live streamed predictions from what exactly has been shown. So if it's still, my model is still trying to infer something that already that the user already is not now being seen by the user, if you drop it and give me something else. So that is why we need to incorporate what we call the result listener and the error listener. So yeah, now I hope you understand why we're having the two of them there, to just help us to make sure that the user is able to see what is happening right now. Yeah. Wow, this is interesting, right? I hope this is interesting and you can get to understand this more. So then you finally create a new options and use it to create a new image classifier object, which is going to be what we use to do all the work. So for the other thing, we're just creating what we had created earlier. We're just creating, like, this is like is what you call is like a template. It's like what is exactly there. But I want to now exactly have my what is going to be doing the work. What is going to be doing the getting the frames, the different, getting the different frames and classifying all of them. So that is what I'm doing here. I'm just creating the one that will be working for me. We usually say that the youths are the workers of a nation. So here I'm creating the youth of this nation. So that is actually going to do the work and give me the result. So this is what I'll be doing here. Okay. Now let's see what we have here. So now proceed to the next part. So as for getting images into my classifier, I'm not going to get, far into that detail because, this is it's going to be so easy. So what you can see here is you're using a camera X. So my user is using a camera X. My user might be on an iPhone. My user might be on a Pixel device. My user might be on a Techno device. Or my user might be using, a mobile device that has buttons. But still it has a camera. So it's a camera X. So this camera X will create an image analyzer on top. So I'll be creating an image analyzer on top of to process those frames. So I'll be creating an image analyzer on top of that to process those frames. And for this model, it is expecting, so now we can see here, it's expecting an image format of RGB 888. So you can see in that part, it is expecting an Apple, or in the part where you have image analysis dot output underscore image format underscore. Okay, how about chat? Okay, sure. So we'll just proceed. So because you have different cameras and you know that this app is going to be used by users with a specific type of camera. So you know your users. So what you're just trying to say here is that you're going to be using this this specific type of image format, so that if someone is on a pixel, so you can decide to put the lowest image format so that even if someone is on a very high quality camera, they're still able to get results from it. And if someone is on the lowest, the one that has the poorest quality of images, they're still able to get inferences from whatever. And then you have what we call this aspect ratio. So aspect ratio is images are of different pixels. So this one might have been taken on portrait mode, and this one might have been taken on landscape mode, and this one might have been from a phone, this one is a screenshot from a laptop, and as you proceed. So with aspect ratio, you're just trying to make sure that all these images are going to be converted to a specific aspect ratio. So for example, if the model was trained by images with 320 pixel by 320 pixel, all these things will still be the same. We still have, so that the images are coming in, we'll have the aspect ratio of 4:3, so that to make sure that these images are at least similar to the model I'm using. And the model I'm using is what I called earlier on. Remember the model I called earlier on is what I'm using here. So we are trying to bring everything that is coming in to be as close as what was used, was used to train our model, so that everything is so similar to that. So that is what is happening in this slide. So now let's see what is. We are nearly over with the code, so that you can now discuss and understand more on the same. So what I'm doing here is just this function is going to take an image proxy object that was created by the image analyzer and then turn it to a bitmap buffer object. So we understand that computers don't understand our human language, and they have what we call bits. We think if you've really understand the basics of how everything runs, is they run on bits. That is what it is trying to do here. It takes the image proxy object that we've created, and it is by the image analyzer, and then turns it to a bitmap buffer object. Exactly. So this is what is happening here. So it pixels from buffer and image proxy and turns it into a bitmap buffer object. But this is not that much, because this will be similar, like we'll be adding this in everything. So it's not so much for you to so let's understand now what exactly. Oops, sorry. Let me go back here. Yeah, so I'm still here. So here now, what is happening, we are going to make sure that the image is, so what is happening is that sometimes someone might upload an image that is rotated, an image that is a close-up, and an image that is probably not, different types of images. So what we are going to do here is we are going to try and rotate our images, so that if someone uploads an image that is upside down of a cat, our model is still able to like get it and understand it. And then we can create a new image or an MPL image. So here just creating a new image or an MPL image that is classified using the classifier sync method. And I'm using the classifier sync method because it's live stream. runs asynchronously, as I explained earlier. Again, use classify async here because it is live stream. If you're going to use static images or static videos, we can just call classify. So I remove the async and have it called as just classify. So now to the last part of the code. Once all that is finished, we'll just end up by passing the result over to the custom listener that is listening. There's always like a listener that is listening to, okay, what am I going to get? So you have a custom listener that is interacting with the rest of our program. And that's pretty much how we do image classification for a camera frame. This is actually the challenging option as you are dealing with a physical camera and doing everything async. So, and for those who have dealt with Android, they know that Android is notoriously tricky with cameras. So it's so hard for me to deal like with cameras and all that stuff. So yeah. Okay. So now after that, this is what you'll be able to get. Once you do all that in your app, this is what you'll be able to get. Now I want to hear from you before we go on. I want to hear your did you like understand what I was sharing, or you have an addition on the same? Because these are interesting things, but at the same time they can be overwhelming. And I was giving an Android example, so that might have maybe put you off for some reason. But yeah, I want to hear from you. If you at least understood some parts of it, even if I say, okay, I'm listening, and I may try it later and learn from it, you can just drop a one in the chat section. If you like, I understood I at least grasp something. I don't expect you, of course, to like understand everything word by word, but I should be able to simplify these concepts for you. You should be able to ask me questions so that I'm able to see, okay, how is my audience doing? Are they understanding this concept, or I should repeat it again? So yeah, maybe I can hear from you. We are just at the top of the hour, so it's exactly 7 p.m. in Kenya, but I'm sure it should be 6. I'm not sure. It should be also at the top of the hour on the other side. So this was a 1 hour session, but I still have probably a lot to cover. But as Precious said, this is we can be doing this time to time. I can always ask for a session, and we can now cover object detection and on web instead of Android. So let me hear from you. And I want to hear from you. Yeah, it's 5 p.m. in Nigeria. So you see, it's now 7 p.m. here in Kenya. It's 1 hour, and I want to respect your time because this session is supposed to run for 1 hour. So maybe I want to hear from you first before we leave this call, because it's a 1 hour call. But let me check. Precious left a message. Oh, sorry. Someone actually added something in the chat section. So initially, this is okay. I'll just say Kanu because I don't want to like butcher your other name. Initially wanted to say that old video frames and live stream could be back pressured to preserve important details that might be visible in that frame. Yeah, that is also great. Since not all frames could contain relevant info, especially designing for people with poor internet connections. Yeah, exactly. If you're having an what you call offline fast design. So let me go to this specific part. Thank you very much for adding that. If you still have a question, please share with me, or you can share, then you can see. Okay, there's a part where I can pause presenting, and then I can go to that specific slide. Okay, but I can still just go to that part. Yeah. So now let's go to this the last slide. So all this is what I wanted to cover with you, but it's exactly at the top of the hour. So I'll just probably go to the last part, share it with you, and then you can. It's time for Q&A already. So if you have a question or you want to share anything, I'm here to assist, and I'm here to assist you on any other part. So yeah. Does anyone have a question before I proceed to the next section? Does anyone have a question that I can handle before I proceed to the other question. So this was also just a part that I'm supposed to cover, but as Precious said, it is we can always cover it. Oops, sorry. Okay, let me do that. Yeah, now we're here. So yeah, just want also what you can do is someone can do me a favor of taking a screenshot and then they can share in the Slack channel and then we can use to post on the socials later on. Okay. It will run on the client. Sorry for that. It will run on the client. I'm seeing questions in the chat section. Yep. Okay. So do you have okay, I think I answered the questions in the chat section, so I'll proceed. Yep. So I just wanted to share some on the last part. So this is if I was doing embedding, but we want to go into that today. To Chuck's question. Okay, for web platform, will the on-device machine learning run on the server or on the client? I said it will run on the client. So yeah, just to keep up to date, I will of course request for another session, and then now I can cover everything on web now instead of Android. So I will shift my focus to web. I'll probably reach out to to Precious, and we can have a discussion, and then I can have another session and then cover web part of it. But just to keep up to date, you can visit developers.google.com stroke slash media pipe, and you can also join the mailing list in case we have any announcement or anything. And also you can reach out to me, or we have this email that when you send an email here, you'll also get support. But also when you join the mailing list and you share, I'm also part of the mailing list. We'll also be able to help you together since many people are part of that of the mailing list. So I'll now be opening the floor to questions, and if anyone wants to share anything on the same, it's not me sharing everything. We're learning from each other. So if you want to add something of it, I think Kanu added something. It's Kanu. Yeah, it's Kanu. So Kanu added something in the chat section, which was really helpful. Thank you so much, Kanu. Also, thank you very much, everyone, for joining till the end. I know, technical sessions sometimes might be challenging, but I'm glad you stayed to the end. So yeah, now it's time for questions. If you have any question, please feel free to ask. I'm here to assist. I'm here to assist on anything because we have depleted our 1 hour and I wouldn't want to take more of your time. Oh, yeah, sure. Yeah, you should expect the web session. It will be so interesting. It will be so interesting. Yeah. But also, if you have any questions on different things, also just outside of this, just outside of all this, I really would love to see if you need any help in applying for the, if you're still in university and you are passionate about communities and you want to apply for the GitHub Campus Expert Program, please feel free to reach out to me, and I would love to assist more. We don't have many folks in the program from Sub-Saharan Africa, and we want to change that. We want to have more people from Sub-Saharan Africa joining the program and also making impact at their own capacity. So if you want, it's a really good program. If you want to know more how you can apply and all that, please feel free to reach out to me. Okay. Yep. I mean the Slack channel, of course. Oh, okay, so let me just drop my session, my links here. Okay, okay, let me just save that and drop this. So let me just drop the link to my LinkedIn profile so that it's easy for you, and also like Twitter, so that you can easily reach out to me. Yep. So here's my email. Let me just drop it in the chat section. I don't know. It's it's behaving, but yeah. Oh, I can actually do it from this side. Mhm. Yeah, it's called X nowadays. So oof, wahala. So you can reach out to me here. And reach out here to me on Twitter. Let me just also drop my LinkedIn. I think I have this. Okay, venture profession. Options. Copy. Yeah. So this is my LinkedIn and my email is there. Yep. So feel free to reach out or connect with me in the session. So we have Divine. Divine, you haven't speaked today. How are you doing? How is everything?